Hey, good evening, guys.
Hey
Hi,
there.
hi, everybody.
Gerald.
Greetings from North Carolina.
Yeah, I'll tell you, we were pretty dysfunctional last week when it came to getting our time straight. Our slide was wrong. We didn't know which end was up. We showed up early, and we just didn't have it together. But this week we clearly do because you have joined us at the exact right time, and you're 3 hours ahead, right?
Yeah,
So
it's
so
12:30 in the morning here.
it's right. It's
Yeah,
12:30 in the morning,
and he's
and
still awake. He's a real astronomer.
and Gerald always tells the truth. He always tells the truth. That's one thing you can count on with Gerald, and that proves that the Earth is round. And
Right.
and you heard it here first, and we can now dispense of all the rumors to the contrary. So anyway, you're probably wondering what you've tuned into, and
Yeah.
Yeah, your logic
this,
is impeccable.
yeah, this is the Chabot Space and Science Center virtual telescope viewing, and it's going to be one of those virtual telescope viewings tonight.
As
I
you can
ran,
see, we're
yeah.
all closed up and
Yeah, it's like the
the
lights are
weather is
on.
bad.
What kind of telescope viewing is this? Well, I guess we could actually view the actual telescope, which is right here behind me. And there's our friend Nellie, which is our
Hey,
36-inch research
different
refractor.
views.
Yeah, it is a different view tonight. The reason we don't have the roof rolled and the scope ready to go is because our humidity shot up to 91%, and we can't use the telescope when it crosses 85. And the reason for that is moisture will condense on the primary mirror and make a mess of things. It becomes a big cleanup job if that happens. So we had to change our plans at the last minute here, and it's unfortunate because it's pretty clear out, right? So those
Yeah.
of you who live in the area have probably figured, oh, they'll be using the telescope tonight, as did we. So that's where we're at.
It
So
is a
anyway,
it
let me
is kind
let
of
me.
windy
Oh,
out too, though. So seeing wouldn't
well,
have been really great, but it would have been better than the ceiling of the dome here.
yeah. Well, I do want to mention that the Chabot Space and Science Center is still closed. Our plan is to open up in the fall. The opening date somewhere around mid-November. In the meantime, though, we depend on your donations and support. And so if you're on Facebook, there's a donate button somewhere on your screen. If you have a phone, an Android phone, it's on the bottom. If you have a PC, it's somewhere up on the top. I think on Gerald's computer, it's right in the middle. I guess we can never seem to agree where that button is. And if you're on YouTube, go ahead and visit us at the Chabot Space and Science Center's webpage at chabotspace.org, and you can make a donation from there. We appreciate any donation of any amount. It really helps keep things going up here and keeps the necessary funding for the internet and all the things we need in order to keep these STEM programs, these live STEM programs going. Also want to thank Fremont Bank, community supporter, for their ongoing support of Chabot and these STEM programs. All right. Well, we do have. I guess when we've closed up the dome, we kind of present the astronomy news of the week. So the big news coming up is the middle of next week. We have, and John got the reason for this correct while we were muted before. We have the super flower blood moon. And I used to think that people were making this stuff up, And then I did a little bit more reading today, and realized that there is a reason for each one of those words, except for including the word moon. That's kind of the obvious one,
Yeah.
right? But super flower blood moon. Okay, so a super moon is when the moon is in perigee with respect to the Earth, meaning that the
The
moon
full
is
moon,
at the full moon is
right?
at perigee. Right, thank you. And that means the full moon's at the point in its orbit where it is closest to the Earth. So it actually not only appears, but takes up more space in the sky. It's a little bit bigger. The flower moon is the typical name for the May moon. So every May, when you have a full moon, it's the flower moon. A blood moon is when the moon is in eclipse. It's eclipsed by the Earth, because when the moon is eclipsed by the Earth, it turns kind of a blood or orange red. So on Wednesday morning at 4:15 a.m., when you're all well awake and fully caffeinated and already out and about doing your thing, we're going to have a lunar eclipse. And at Chabot, we're going to be covering that from 1 o'clock in the morning till about 5 in the morning, assuming, of course, that we're able to use the telescopes and that it's not fogged in and all that, stuff that we always have to deal with. But we are going to have an all-night eclipse program, hopefully. And you can come join us on YouTube and Facebook if you don't feel like getting outside and finding your binoculars and looking at it on your own.
We do have an event up here, but it's a members only event for Chabot members, and I believe it is sold out already.
Yes. But we're going to be interviewing some of those people during our
that's right.
Yeah, we should.
Broadcast.
Yeah. So Gerald, tell us what you're showing us here. That's really nice.
Yeah, this is a set of images taken by Conrad Jung, who is a staff astronomer here at Chabot Space and Science Center. And he took this a couple of years ago when there was another very similar lunar eclipse. And it just kind of shows you the phases that the moon goes through as it passes through the Earth's shadow. The Earth's shadow consists of two concentric rings, if you will. The outer one is what we call the penumbra. The penumbra is a faint shadow. And then the inner ring is the much darker shadow, which you can see here. This is the one that turns the moon kind of a reddish orange color. And we call that the umbra. So the moon will start to pass into the penumbra, the fainter outer shadow, at 1:47 a.m. On the 26th, Wednesday morning on the 26th. And about an hour later, not quite an hour later, it will begin to enter the darker shadow, the umbra. And by around let's see, I got to check the times here. I think it was, around 4:11 a.m., it will be fully immersed in the darker part of the shadow, the umbra, which is when it will have that orange color. But it's not going to last very long. By 4:25, it will already start to creep its way back out again because of the Earth's shadow is much bigger than the moon. So sometimes the moon slides right through the middle of that shadow. Sometimes it moves across one edge or the other. And this time it's going to be moving across one edge.
So it's kind of a glancing blow is the way to think about it. Yeah.
So we're only going to get a relatively short period of time where it's in totality, only about 14 minutes or so. And then it will start to emerge from the shadow and continue on. By the time it's about halfway out of the umbra, it will be close to dawn for those of us here in the Bay Area. So we won't be able to see the complete eclipse, but we will definitely see totality. And as Richard said, we will be covering that. We will be live streaming it from Chabot on our Facebook and YouTube pages starting at 1:30 a.m. And we'll probably run until about 5 o'clock or so. And we will have guests up here as well. And Richard has promised that he's going to go into reporter interview mode and interview some of those guests during the eclipse. So we all got to make sure.
We'll see how that goes.
that ought to be very entertaining.
Yeah. Keep your fingers crossed that the weather cooperates, because we do need to have clear skies in order for this to happen. And we're probably going to be using more than one telescope to do this. So this will be a little bit unusual. We'll give you some views from some different telescopes. So you want to be sure to join us for that event. right.
Lydia asks a really good question, and it's one that I was kind of wondering myself is how we're planning this. On Wednesday, if there is clouds or partly cloudy or fog, will we continue anyway and wait to see if the sky clears up, or what are we going to do?
Oh, that's a good
Yeah.
question. I'm not
What
sure.
are we going to do?
I see. I'm not alone in this.
Sounds like we're going to punt.
It sounds like we're going to be winging it, is what it sounds like.
Yeah, what we may end up doing, I'm sure there will be other observatories with better weather
Right.
who will also be live streaming it. So we may have to latch on to one of those observatories.
Oh, that's a really good idea. Yeah, we could do that.
We'll show their video and we'll provide our commentary because our commentary will be better than theirs will be.
So it'll be something like Mystery Science Theater 2000.
There you go.
Where we're looking at somebody else's.
I'll be at the bottom of the screen.
That's right. All right. Very good. Well, I think we can pull that off. All right. Well, thanks, Gerald. I had a different image I wanted to show with respect to the eclipse, just in case anybody is still confused by what is going on. Let me find my Zoom screen here. Bear with me. Sorry. Here we go. And I'll share my screen. So you can see what Gerald was talking about. The sunlight is coming in and it hits the Earth, and the Earth casts a shadow. And if the moon passes anywhere fully within that shadow, it is a total lunar eclipse. And the reason it's red is because light hitting the Earth's atmosphere refracts, much like a prism. All right, the atmosphere acts like a prism. So the red light gets bent in toward the moon, into the interior of the shadow. And the red light then illuminates the moon with that blood red color. So this is a different way of looking at it. And the umbra is the total shadow, and the penumbra is the partial shadow.
This is an interesting diagram here. It's very much not to scale.
Right. Oh yeah, it's definitely not to scale, folks. Yeah, not to scale. If it was to scale, we'd have to have multiple laptops.
Yeah, the moon is way out farther than that.
Yeah. And one of the things, if you were on the moon looking back towards the Earth, it would be as if you saw a sunset all the way around the circumference of the Earth.
Wow.
So the sunlight is being refracted. And, you know, at sunset, you know, here on Earth, when we see the sun setting, we often get a red sunset. Well, the same thing is happening here, except it's all the way around the circumference of the Earth.
So it'd be like a ring sunset.
Right.
Yeah.
Wow.
Yeah.
All the way around. Worth taking a trip to the moon for.
Yeah, it certainly would be. Yeah. All right. Do we have any other questions about the eclipse coming up? Now's the time to ask, and if not, we'll move on to the next thing. And Jasper asked, "What's the humidity doing?"
Yeah, it's not doing much good.
What's it at?
93%.
No, it's only going up, man. Yeah.
Yep.
I think we're kind of skunked for the night, no doubt. Sometimes it goes down. Sometimes it does, but I don't think tonight's one of those nights.
No, we had an event up here last night, and the weather is very, very, very similar to last night, and we did not have much luck last night at all. We observed only for a few minutes, and then humidity went up, and we had to close all telescopes.
The joys of astronomy in the Bay Area.
Right.
Now, out here in North Carolina, where I am, the sky is perfectly clear. The humidity is low. So, unfortunately, I don't have a telescope.
You didn't bring your telescope with you. What's the matter with you?
No, I didn't. Yeah, really. So, Richard, you said something about a new.
Yes.
Yeah.
I was sitting there looking for questions and reading something that Debbie had posted, but let me put this up just for a moment here. And...
Yeah, let me jump in here while you're doing that. Debbie did post a link to our weather station.
That's
So
what it
you
was.
can click on that and get our local weather here right at Chabot anytime you want.
All right.
And the really important number is the humidity number. That's the
Right.
one we all pay attention to.
Okay, so you're probably wondering what this fuzzy blob is that I put up on my screen.
Yeah. What
All
is
right,
that?
so, well, what this is the oldest or earliest spiral galaxy ever discovered through a telescope. And as you know, as we look at distant galaxies, we're looking back in time. And the farthest back we're able to see is the cosmic background microwave radiation, which is about 14 billion years ago. And that's about the time, just slightly after the time, that the theoretical Big Bang occurred. And this galaxy, if it's dated correctly, existed just 1.4 billion years. Just 1.4
That's
billion years.
1.4.
Just 1.4 billion years after the Big Bang. That's over a billion years older than the previous record holder for a spiral galaxy. Now, it doesn't have a very appealing name. It's called BRI 1335-0417. Now I want you to remember that, guys. There will be a test. That's BRI 13350417. It appears to have a central bulge, as you can see in the center. Is much brighter, much like typical spiral galaxies do. It appears to have a rotating gas disk and spiral arms, and it also looks like it, based on the spectra. If we look at it through a spectrograph, it's also pumping out newborn stars at approximately 5,000 suns per year. Right, that's a pretty fast birth rate for stars, and so it makes it what's called a starburst galaxy. So any galaxies that are pumping out stars that quickly are called starburst galaxies. And it was discovered by Takafumi Tsukui and Satori Iguchi at the Sokandai University in Tokyo, and they were using the Atacama Large Millimeter Submillimeter Array radio telescope in Chile. So this is a radio telescope image, not a optical telescope.
And Richard, when did they discover this?
This was, that's a great question. The articles I read didn't put the actual date that the discovery was made, but this data and description was released just this month, and so I am assuming that this was probably 3 to 5 months ago.
So a pretty recent discovery then.
Very
sure.
recent discovery, yes.
Cool.
Yeah.
Mm-hmm.
Very old.
Yeah. All right.
All right. Let's see if we got some more questions. John, do you see anything new on the Facebook side?
There's something here.
I have something hot off the.
I can't see the whole message here, but it says, "How do we know the moon will be fully dark? Is there a?" And that was the end of the message. So.
Is there a name for that shadow?
Oh, okay. Oh, I see. And then Alan answered that, the umbra. Okay.
Yeah, that's what the umbra is.
Yeah.
Right.
Yeah.
And we will usually be able to estimate the extent of that darkness based on the proximity to the edge of the shadow. So when the moon passes directly through the center of the umbra or through the center of the Earth's shadow, it's the darkest possible eclipse. Whereas when the moon passes more towards the edge, it's different shades of orange. And we'll know that in advance just by the fact that we understand very well the orbital elements of the moon.
Here's one. Did you hear the recent news about the Methuselah star? I did.
Oh, yeah.
Either of you?
Yeah, I did hear about that. This is a star that I believe is in Libra, if I remember correctly. and it's 700 light years away, and it's about as old as that galaxy we were just looking at.
Wow.
It's a 14.1 billion year old star that's 700 light years away, which is pretty remarkable. And so it's called the Methuselah star.
I get it.
And yes, and that's why. But it's here in our Milky Way, and it's remarkably close. It's 700 light years is very close in the overall scheme of things.
Must be a fairly low mass star then.
Yeah, it's very dim, and it's a very dim red star. And the magnitude, though, is not out of the question for a telescope like Nellie. It may be something we might want to try to look at someday.
Yeah.
So yeah, thanks for bringing that up. I was sitting there pondering the fact that here was a 14 billion year old ball of gas sending photons out to Earth that took 700 years to get here, but the age of that star is remarkable, and it just goes to show you that stars do not burn up their fuel very quickly.
The one who posted the question, Richard, said its measurements showed it to be older than the universe. That's interesting.
Well, that's
I don't know how that's possible.
Well, it means that the mechanism for measuring close by objects differs from the mechanism for measuring distant objects,
and things,
and there are all kinds of contradictions when you try to calibrate those two measurement types, and it always brings up the uncertainty of whose measurements are actually correct. So either the universe is older than we thought, and it seems to always be getting pushed in the older direction. And we're always thinking, well, maybe it's older, or the mechanism used for measuring the age of this star, because it's a nearby star, we're using different tools, is not properly calibrated and is wrong. So they'll have to figure out which is the correct thing over time.
You also have to remember that the mechanism that we use for measuring the age of stars has a pretty large error factor, plus or minus 10% or more. So that number may be the result of a lot of calculations and be the average of a bunch of different solutions. So it could be younger, it could be older, but you're dealing with a lot of ambiguity when you start building on information that you gather from the star based on spectroscopy and other factors. You start introducing some pretty wide error bars in that. So take that number with a grain of salt.
Yeah, it's actually harder to measure the age of close by objects than it is to measure the age of very distant objects. Because the very distant ones, we're using redshift. We're just basically saying, okay, the spectrum is shifted by that amount, and we have an assumption about the expansion rate of the universe, and we put that shift together with that known expansion rate, and we're able to come up with a pretty consistent estimate of age. But what Gerald's talking about is we're kind of looking at something really close by. There is no redshift to be looking at. We're not judging its age by how far away it is from us. We're looking at its chemistry, essentially, to figure out how long it's been there based on what materials are present in the star or not present.
Not only that, but when you look at a star with a spectroscope, you get a rainbow with little dark bands in it. And the width of those bands is actually related to the age of the star. A very young star is going to have very wide bands, and a very old star is going to have very narrow bands. But you're still, like I say, you've got a lot of room for error in those estimates based on things like that. So there's a take that number with a grain of salt, but it's in the ballpark, but plus or minus 10%.
Yeah, when we age, we get wide bands too.
Right.
Yeah.
Usually around our waist.
Yeah. And just like stars, we swell up. And speaking of old stars,
I hope we don't collapse at the end of that, though.
Yeah. Speaking of old stars, we had an event that just came up today. In fact, at 1:37 p.m. this afternoon, we had an event that was discovered by an observatory in Czechoslovakia. Actually, the Czech Republic. It's not Czechoslovakia. I'm showing my age. It's called the Czech Republic. And they discovered a nova in the galaxy M81, which is a galaxy which is in our night sky right now. And if the weather wasn't bad, we could be looking at it with our telescope. But the astronomers in the Czech Republic discovered a nova. And a nova is a very bright, explosive event on a star. It's the result of a white dwarf star remnant that's orbiting around a giant star. Stars often occur in binaries. In fact, we think probably more than half the stars we see in the night sky are actually binary systems, two stars orbiting around each other. Those stars don't necessarily have the same mass, so they don't age at the same rate. And typically what will happen is one star will reach the end of its life. It becomes a white dwarf. A white dwarf is a very small, compact object, very high energy being emitted by it. And then the star next to it ages at a slower rate, but eventually that star swells up and becomes a red giant. And when the two get close enough, the white dwarf can start to pull off matter from the red giant. In fact, if I can share my screen here for a second, I can actually show you a graphic, give you an idea what I'm talking about. So here's the white dwarf. The white dwarf is very small. It might be only 10,000 miles in diameter, whereas it was once a star 1,000,000 miles in diameter. It's in a binary system, so it's orbiting with another star which has aged a little slower. So it has become a red giant. And as that red giant gets big enough, the white dwarf starts to pull the outer layers of hydrogen off the red giant. And it goes into what's called an accretion disk around the white dwarf. And some of this material then falls onto the surface of the white dwarf. White dwarf is extremely hot, and the hydrogen builds up on the surface until it reaches enough density and high enough temperature to start fusion, hydrogen fusion into helium. And when that happens, it happens explosively. And that produces a bright flash. Material is blown off of the star. And we see it as a very bright flash out in another galaxy or even in our own galaxy. And so that's what's going on right now in M81. So what they spotted was, just M81, which looks like a galaxy with, not very distinguishable individual stars. And then all of a sudden, one star shows up, and it shows up very bright compared to the rest of the galaxy. And that's the nova that's happening right now. So that was in M81, just discovered this afternoon. And like I say, if we could view with our telescopes tonight,
we'd be able to see it. Yeah.
Yeah.
What's the difference? So tell us the difference between a nova and a supernova.
Okay. Well, there are two types of supernova. One is called a type 2 supernova, which is when a very massive star reaches the end of its life and it basically explodes. Now, that only happens to very massive stars, say a star 20 times the mass of the sun. When it reaches the end of its life, it explodes in a supernova. And that's called a type 2 supernova. A type 1 supernova is a very similar process to what we just showed. So I'll share that image again here. It's a very similar process where material is being pulled off of an adjacent star and it piles up onto the white dwarf. And the white dwarf, the mass of it increases and reaches a critical point of about 1.4 times the mass of the Earth, or of the sun rather. And at that point, it's got so much mass, so much energy, it explodes in what we call a type 1 supernova. So that is a much more energetic event. It produces a much brighter flash of light. And it can be easily distinguished by the elemental composition. A nova produces a lot of helium. A supernova does not. Produces a lot of hydrogen instead. So there's characteristics that distinguish the two of them. Also, the amount of time it takes to ramp up to full brightness and then fade out. Type 2 supernova fades out, ramps up very bright, then fades out in a very slow process where it plateaus and then it finally drops off. Whereas a type 1 supernova ramps up and it just fades out at a very gradual rate. There's no plateau. And there's some other distinguishing characteristics.
And which of those supernova types leaves behind a neutron star?
Most likely the type 2 supernova leaves behind a neutron star.
There's a reason I ask. One of the other discoveries that's related to what you're discussing, in recent weeks, it's been announced anyway. So the Chinese have a telescope that's very similar to the Arecibo radio telescope that self-destructed not long ago, last year. So they have a similar telescope in a valley that is doing very similar types of research that Arecibo was doing, and they have discovered 129 new pulsars. And pulsars, and these are all in the Milky Way, and pulsars are remnants of the types of supernova that Gerald was describing. They are neutron stars, and the characteristics of a neutron star, the main characteristic of a neutron star, is that it spins very quickly. And every time it makes a rotation, it sends out a pulse of energy that we're able to pick up with a radio telescope. And each pulsar that's discovered has a different timing in between those radio pulses. So that's kind of their signature. So anyhow, they've made these pulsar discoveries that are remnants of supernova.
Right.
Yeah.
Cool. So how are we doing on questions?
We've got a couple of interesting ones on Facebook. We have to go back to the lunar eclipse.
That's fine.
One of the questions was, has there ever been a photo of a lunar eclipse taken from the moon? I don't believe so. Are you aware of one? They'd have to have left a camera up there, and not sure how they would control it. The next one, though, is, are we having more blood moons than many years ago? I don't believe so.
No, in fact, this is the first total lunar eclipse that we've had in 2 years. So
yeah, there's more coverage of them, I guess, than there was.
Yeah, it's like everything else, right? Yeah, it's like the stuff that happens at pretty much the same rate, but we just hear about it more quickly.
Mm-hmm.
So maybe that's what the difference. Maybe that's what the difference is. All right.
Let's see what we have on.
How long will the white dwarf be visible, do you think? to us, the
You
the
mean
Nova,
the
Nova
Nova?
in M81.
Yeah, a couple of weeks.
Got it.
Yeah, so it's
So if I want
possible
to
we'll still be
photograph
able
it,
to
I
see
got to
it.
get on the stick here and
Right.
That's right. Just point your telescope at M81 and it'll be there.
yeah.
Given the time delay, how many years ago did the recent nova actually happen? How far away is M81? Do we have a
Oh,
distance?
I always forget that, isn't it? It's I want to say it's 12 or 14 million light years away, but I might have it may be 20.
Well, if you'll stand by, I'll look that
I'm
up.
searching it right now.
Yeah, if only we had a device where you could just look things up.
Looks like about 12 million light years. So
So
that
it was
happened
12.
about 12
Okay.
million years ago.
Yeah.
Yeah, that's one of the things about looking out into space. Anything we see happening, we see it the way it looked at some time in the past. So if it's 12 million light years away, that means we see the event we're seeing right now actually happened 12 million years ago.
Here's a good
And that's
question.
true regard.
Sarah asked, "Why do we call our galaxy the Milky Way?"
Yeah.
My first reaction was product placement, but
Right. It's a candy bar.
yeah, no, I don't know the answer to that. What's the answer to that? Do you guys?
Well, the
know
answer to that
Well,
is the look of it, the appearance of it in the sky. It's so many stars that it looks like just a streak of milk pouring through the constellations.
But who came up with that term, and how old is the term?
That goes back probably 2,000 years at least. Back when you went outside at nighttime and you could actually see the night sky.
And you could actually see the Milky Way, right?
Yeah. You would see this bright band across the sky. The Milky Way, you really don't see it as a bunch of individual stars. You see it as kind of this bright, kind of foggy appearance band across the sky, and it looks sort of white. And so ancient peoples began to call it the Milky Way. It looked like a river of milk across the sky, or a milky road across the sky.
Well, Tim Thompson was chiming in. Tim is a regular viewer of our presentation here, and it's great to have him around. He's on the board of the Mount Wilson Observatory and loves to jump in on Saturday nights and watch us for some reason. But he mentioned that the Milky Way, of course, originally was named from the Greek and Latin terms, and so yeah, you're right about the age, because it would have been Greek.
Yeah.
Mm-hmm.
So don't they have anything better to do down at Mount Wilson?
That's what I was wondering. Yeah, Tim, what's going on?
Maybe it's foggy there too.
Yeah.
I'm sure you guys have better weather than we do.
All right.
Well, how are we doing on other questions?
Anything on YouTube?
Well, let's check it again. Maybe that has changed. Oh. Can you describe a quasi-star?
Quasi-stellar? You mean a quasar?
I don't know.
Maybe means
maybe that's what he means. Yeah, it specifically says quasi-star though, not a quasar. So I'm not sure.
Quasar is an abbreviation, if you will, for a quasi-stellar object,
Okay.
Which is a term dating back, I think, from the 1960s. What it is a very young galaxy with a very active black hole at the center. The black hole is actually consuming gas and maybe a few stars along the way. So it's what we call an active galactic nucleus. And it produces a lot of radio emissions in the radio part of the spectrum. So when they were first discovered, that's how they discovered them, is that they were getting these strong radio emissions from these things. And eventually they matched them up to these very distant, bright objects that are, in fact, very young galaxies with a very active black hole at the center. And we call it now a quasar, which is a combination of the words quasi and stellar.
They're very energetic and they're very bright, and they tend to be very distant because it's a phenomenon that occurs in very mature galaxies. So very old galaxies have this phenomenon going on. Okay, Tim got back to us. He says it's clear at Mount Wilson tonight. And so he's probably wondering why he's watching us also.
The moon is too bright for observing interesting stuff.
Yeah. Larry,
tell him I said he's a bum.
Larry asked, do different power telescopes see an object at different times? The answer is no. All right, so think of it this way. The light coming from these distant objects, let's say there's a galaxy 10 million light years away. The photons, all of the energy coming from that galaxy and hitting the Earth, whether it's our eyeballs, whether it's a telescope, whether it's a radio telescope, took 10 million years to get here. It doesn't matter whether the telescope is big or the telescope is small. Those packets of energy are still going to be 10 million years old. The difference between a small telescope and a large telescope is that the large telescope will be able to resolve the detail better because it gets more of the energy. So the more energy we're able to detect through a radio telescope, or the more light, that light is a form of energy, the more light we're able to detect through a optical telescope, the more resolution of the object we will get, the more detail we will be able to see. So that's how they differ.
We got a comment about the photos of the lunar eclipse from the point of view of the moon. There have been many of them, but they're all alien in origin. I'm not sure where that information came from, but somebody knows something, I guess.
Yeah.
Yeah,
the Chinese rover on the moon is on the far side of the moon, so it will not, it always sees an eclipse. The Earth is always eclipsed by the moon.
By the moon.
Yeah. Every time they point it at the ground,
it will not see the Earth. That's right.
Right. So another piece of news that came up is about the James Webb Space Telescope, which is the next generation space telescope. It was scheduled to launch at the end of October. However, it looks like that may be delayed now. The James Webb Space Telescope has been delayed numerous times. I think the original launch date was like 2013 or something like that. And they've had lots of problems with the spacecraft, with the telescope itself. It's very unique technology, and it has to work right because it's not going to be someplace where we can just send astronauts to fix it. Like
it's not serviceable. Yeah. It's got to work. It's got to work right the first time.
Absolutely, one shot. That's
it. Right. So there's been numerous delays: 2013 and 2015 and 2016. The latest was it was supposed to launch on October 31st, but it looks like it's going to be delayed again. But this time the delay is not because of the telescope itself; it's because of the launch vehicle. The James Webb Space Telescope will be launching from French Guiana, which is on the northern coast of South America. It's a very convenient launch site because of its proximity to the equator. And a launch vehicle was going to be an Ariane 5, which is a European Space Agency launch vehicle. And apparently they're having problems with the launch vehicle. So it's looking like the James Webb Space Telescope will be delayed once again for a different reason this time. But when we find out what the new launch date is, we'll be sure to let you know. And we're going to try to maybe cover that a little bit from Chabot, do a live stream during the launch.
Yeah, that would be.
But
But
stay tuned.
as Tim said, the James Webb Space Telescope is delayed a year in perpetuity. So
Yeah,
it's,
right.
hopefully, it's like the old nuclear fusion joke. The fusion will always be the energy of the future. But
Yeah.
we'll see. Maybe they'll, it's encouraging that it's the launch vehicle this time and not the telescope itself.
Yeah.
So,
This telescope is really
better.
cool. It's going to be primarily designed to look not in the visible part of the light spectrum, but in the infrared part of the light spectrum. Infrared light penetrates dust clouds in space much better than visible light does. And so a lot of things that you see kind of faded out in visible light because you're looking through clouds of gas and dust, they show up much clearer when you're looking in the infrared part of the spectrum. So this telescope, although it will be able to do some visible light observations, it's primarily an infrared telescope. And it will not be in orbit around the Earth. The Hubble Space Telescope orbits around the Earth, which makes it easy to get to, or made it easy to get to with the space shuttle, which allowed a couple of servicing missions. But the James Webb Space Telescope is going to be at what's called a Lagrange point. And that's a point where the Earth's gravity and the sun's gravity are balanced. And that point is about not quite 1 million miles away from the Earth. So it's pretty far away. And what the spacecraft will do is literally orbit around that point. So if you were out there, you'd see it orbiting, but it would be orbiting around empty space. But it's just staying within that tight little area where the sun's gravity and the Earth's gravity balance. That gets it away from a lot of the interference caused by the Earth. And then the other thing they're doing is they've got a huge sun shield on it, which will block the sunlight. So they'll always have a dark sky, if you will, because they'll always be looking away from the sun. So it's going to be a really great telescope once it gets there, but getting it there has been the challenge.
Because it's infrared, is it also going to be a better instrument to be looking back to the very early universe? Because everything is redshifted so much, are we going to be able to now see infrared evidence of cosmic events closer to the Big Bang?
Well, things that are redshifted, you can still see them in the visible part of the spectrum. It's just that instead of light being in the green part of the spectrum when it left the object, because it's redshifted, it's shifted over towards the red side of the spectrum. So what if you were close up to that object and moving with it, it would look green, but when it's redshifted, because it's moving away from you, it looks red. So that's the redshifting. So something in the visible parts of the spectrum can be redshifted to the point where it's in the infrared part of the spectrum if it's far enough away.
Right.
So, one of the characteristics of the expansion of the universe is, and this is going to sound weird, but the farther away it is, the faster it's expanding away from us. And it's a weird concept. It can be demonstrated, sometime when Chabot reopens, maybe we'll get people up here and we'll actually demonstrate it, because you can actually demonstrate it with an elastic band and putting some pieces of tape or attaching something to it. You can demonstrate why this happens. But conceptually in your mind, it's kind of weird that the farther away it is, the faster it's receding away from us. due to the expansion of the universe. The faster it's receding away from us, the greater the redshift. The redshift is caused by stars or galaxies, what have you, moving away from us at very high velocity.
Thanks.
So it's a fun demonstration.
So that would be a yes. So in answering my question, I think that would be a yes.
Yes. Yeah.
Okay.
Yeah.
Good. All right. Thanks.
So,
yeah, that was a good explanation.
You don't ask me a question and expect a one-word answer.
Yeah, I know. We would have been.
Don't worry,
we would have been finished
never
at
expect that.
We would have been finished at 9:45. All right. The galaxy that I showed that was 14 billion light years away. How much has it changed in 14 billion years? Who knows?
We don't know. We can't.
We don't know.
We're just seeing it for the first time now.
Yeah. I mean, you can make certain assumptions that it's probably gone through an entire life cycle. It may no longer, and probably is no longer, a spiral galaxy. It's probably some kind of elliptical galaxy, or whatever is beyond elliptical galaxies in galactic evolution. So it probably looks totally different, and may have even dispersed due to stars burning out over time, and the gas from those stars dispersing, and the galaxy losing some of its cohesion. So who knows? We can only speculate.
But ask us again in 14 billion years,
Right.
and we can tell you.
I'll be sure to jot this question down, and we'll
I'll have a much
to
better
it
answer by then.
We'll have gotten better at this by then.
Here's one. Should the Arecibo radio telescope be rebuilt? Yeah, it should be, but I don't think that's ever going to happen.
They got funding to do something.
Did they?
Yeah, there was funding
Really?
that was discussed, and I believe there's going to be an attempt to do something. I don't know the details. Yeah, thanks, Tim. It says Tim said there is a plan to rebuild Arecibo as an improved telescope, but yeah, there obviously has to be money put in place.
Yeah.
There's always a plan, but it has to translate to funding. But at least there's hope.
Oh.
Yeah, you mentioned the Chinese radio telescope. I found an image of it here. I'll share with you.
Oh, yeah, please.
Here, there it is, right there. Yeah, so this is the Chinese radio telescope that just opened a couple of years ago. It's actually bigger than Arecibo, and it has some really unique features underneath it where it can actually manipulate the shape of the disc and the orientation of the disc. So it's pretty cool. But hopefully we'll get Arecibo back soon.
Yeah.
That would be nice.
All right. Let's see if there's any other questions. I don't see any new ones on Facebook here. How about on YouTube? Anything there? No?
Was any information provided about what the issue is with the launch vehicle, I guess, for the James Webb?
My understanding is they had a couple of failures and for that rocket, and so they are delaying all launches for that particular model, and until they work out what the problem is. They had, they promise a certain degree of reliability on their launches, and I guess it dipped below the expected acceptable failure rate, or above the acceptable failure rate. That was my understanding. I don't know, Charles. Is that right, or is it?
Yeah, I'm not sure. I haven't had a chance to look into all the details. They just announced this a couple of days ago. So
Yeah.
And I've been traveling, so I'm kind of behind the times here a little bit.
Yeah, the destruction of Arecibo, Sabino was asking, would it be easier to attempt to reuse the parts? You'd certainly want to reuse the location. It's a good location, and it's the right shape valley, just like that location that you saw on the Chinese telescope is kind of ideal for putting a a metal bowl into. But the parts, I mean, it needs to be redone from scratch. I mean, it was such a massive failure of the structure that you'd really want to do it afresh using lighter materials, probably a new design with greater flexibility and newer technology.
Yeah, it failed because the structure of it was just so old and in such bad shape.
Yeah.
Yeah.
Now, and radio telescopes are much bigger than other types of telescopes because the wavelengths that are being studied are much bigger, right? We're dealing with
Much
light
longer,
that
yeah.
has wavelengths that are meters, and
In some cases,
rather
yeah.
and rather than nanometers
Well, and
or
also a lot of
microns.
times you're dealing with very weak radio signals, so you need a big
Yeah,
dish to
that's
gather
right,
that up.
and amplify it.
Yep. All right.
Well, I think we did pretty good tonight. We
Not
had
bad for
Considering a bad
foggy
weather
night.
night.
we had the dome closed, and we managed to talk for an hour and got a lot of good questions and had a good time doing it. So that's a success.
So let's just remind everybody, Chabot Space and Science Center is still closed, although we are slowly working our way towards reopening. But in the meantime, because we don't have regular visitors coming to the facility, we don't have the revenue that would generate. So we do rely a lot on those donations. So if you'll take a moment to click on that donate button wherever it is on Facebook's page, or you can go to the Chabot Space and Science Center website. It's chabotspace.org. And when you get to that website, you'll see a donate button at the top of the page. Click on that and help us out. We'd really appreciate it. And if you have an employer or you are an employer who likes to donate to nonprofits, we would certainly welcome any assistance you're willing to give us. We would really appreciate that. All right.
All right. Well, thanks for joining us tonight, and thank you guys for helping out tonight, and Gerald for staying up so late. Yeah, I guess you're practicing for Wednesday.
Right.
You got it. Yeah, I'm going to do an all-nighter on Wednesday.
All right. All right. Well,
we'll see you Wednesday, hopefully, if not next week.
All right.
That's right.
Okay.
Good night, everyone.
guys
Have a good weekend. All right.
Good night.
Good night.
Bye-bye.